Hello, this is part two in a two-part series about factoring. In this part of the series on factoring, we're going to talk about factoring trinomials where the leading coefficient is 1. It's not important that you know what that means at the moment if you are unsure, but it really is so that you know that this is kind of the midpoint of factoring. Please make sure that you do complete the practice between the videos. It's really important that you're getting practice because these ideas build on each other. So if you have not yet watched part 1, please go back and do that. So just a reminder that factoring is changing the form of the same function, and I'll talk a little bit more about this in a moment. We need to know how to factor to be able to graph equations, and that's really going to be coming up in the next lessons that we're talking about next week or the week after. So a couple things that we need to be really sure that you're aware of. This here is something called a binomial. There are actually two binomials, binomial 1 and binomial 2. It's called a binomial because like a bicycle, there are two parts. Well, there's two parts here and another two parts there. This is very different than something called a trinomial. A trinomial has three parts, 1, 2, 3. So it's like a tricycle has three wheels, a trinomial has three parts. And these are two binomials because they have two pieces, 1, 2. So these two things are very highly related, and I'll talk a little bit more about that as we go, but I want you to notice that x plus 3 and times x plus 7 will soon become something similar to this. So when we learned about multiplication, we learned how to multiply to go from a binomial to a trinomial. So I'm going to re-demonstrate how multiplication worked as we learned it in class. We have two parts, so we're going to build a 2 boxes by 2 boxes because it's going to be x plus 3 times x plus 7. Using multiplication, x times x is x squared. 3 times x is 3x. X times 7 is 7x. And 3 times 7 is 21. Now, if you remember with multiplication, we needed to combine the like terms, and those happened on the diagonals. The like terms did happen on the diagonal. So x squared, there's only one on the diagonal, so it's going to be x squared. 3x plus 7x is 10x. And 21 is just 21. So in factored form, we have x plus 3 times x plus 7. And in standard form, we get x squared plus 10x plus 21. And this is standard form. And remember, we are working backwards to find factored form. So this up here must have been factored form. And we'll learn how to go backwards when we're going backwards. Something peculiar that I want you to really pay attention to here is that if I look at these two, I'm going to notice a pattern among today's activities that 3x times 7x, 3 times 7 is 21. Well, x squared times 21 is 21x squared. 3x times 7x, the diagonals are actually equivalent when I multiply them. And we'll explore this again and again, so if you didn't catch that right now, that's okay. But when I multiply the diagonals, they multiply to be the same thing. That's going to be very helpful later. So with factoring, we're doing a process in reverse. So if we're going to go from a trinomial to a binomial, I know for sure that it's going to look like this. We're going to undo the multiplication, and what came in was x squared came in. I'm going to reserve this to be 10x, and we're not going to put anything in there because we don't know for sure that it exists there, and this has to be 21 in this box. Well, unlike the common factor, we can't easily undo. So we need to start thinking, what two numbers add up to 10? What two numbers add up to 10? Well, we could put 5 and 5. Would that work? Well, no, we can't because the diagonals have to multiply to 21. These diagonals have to multiply to be the same number. What do I mean by that? if I take 21 and I break it down, well, what things add up to 21? Well, 1 times 21 is 21, 3 times 7 is 21, and that's about it. Which of these pairs adds up to 10? Well, 3 and 7 add up to 10, so 3 of those x's have to go here, and 7 of those x's have to go here. And now we're going to factor out common factors among rows and columns. So in this row, x squared and 7x, the common factor is x, because that's the only thing that those two things have in common. Well, to get 7x, this up here had to be 7, because 7 times x is 7x, which makes the bottom part have to be 3, because 3 times 7 has to be 21. And finally, something times 3 has to be 3x, so that something has to be x. And in factored form, we get x plus 7 times x plus 3. Now you might be asking yourself, why did we have to do this business? Why did we have to do this, what two numbers multiply to 21 that add up to be 7? Why could I not just do 5 and 5? Well, the reason you cannot do 5 and 5 is because if I did this process all backwards, if I started to go backwards in this process, I would not land here. And let me show you why. I'll do a quick example off to the side here. If I were to do 5 and 5 instead of 7 and 3, if I did, we know this is going to be x squared, we know this is going to be 21, we know this has to add up to 10x. Let's say we did 5x and 5x. Well, yeah, I get an x there is the common term. This has to be 5. Well, what number times 5 is 21? It becomes unfactorable. We need to know those two items in the middle. So it's really important. We're going to practice this a lot, and I'm going to give you lots of opportunities to practice it again as well. So why do we need to know this? Okay, so here's a graph of this function, and right now you would never know how this looks, but when you start graphing it, I use Desmos to graph it. Remember that the factored form of this trinomial are these two binomials. And check it out, 3 and 7 are prominent pieces of this function. Well, look at the x-intercepts. The x-intercepts happen at -3 and -7. So there's something about this factored form that is really beneficial when we start graphing. So we're going to go through a few examples where you are practicing multiplying. Really the key here is to think about, we've got a box. We're going to put x squared is for sure going to go there, and 20 is going to go there. We need something that multiplies to 20 that adds up to 9x. We need something that multiplies to 20 that adds up to 9x. And so I'm going to use a table potentially. I'm going to start making a list of things that multiply to 20. And so here's my list. We're going to do 1 times 20 is 20. Okay, 1 and 20, 2 and 10, and then there's 4 and 5, and there's 5 and 4 and 10 and 2, but we've already captured those. So if I start looking at these, which of these pairs add up to 9? Because we need two things that add up to 9 that multiply to 20. So if I start adding them up, this is 21, that's not going to work. This is 12, that's not going to work. And this is 9. So we know that one of them has to be 4, and the other one has to be 5. And from here, we're going to use the greatest common factor idea from part 1 to start pulling common things out. And you can start pretty much anywhere you want. Last time we started right here. This time let's start up here. 5x and 20, the common factor is 5. There's nothing else. There's no more that you can pull out. You can't pull out an x because this cell doesn't have an x. And so that makes this have to be x. If this is x, this has to be x too, because x times x is x squared. And last but not least, if this is x, oh my gosh, why is it doing that? If this is x up here, then this has to be 4. So now we've got our standard form. Our factored form is x plus 5, and x plus 4. X plus 5 and x plus 4. So our goal here, our entire goal for this video is to try and get it into factored form. I've got another example for you because I think it's also incredibly helpful to start thinking about it with negatives. So with all of these problems, you're going to start with a regular 2x2 box, which is kind of why I like these. They're all starting out the same. And the first number is always going to be the top number in the equation, and the last number is always going to be this last number. And I just noticed that it's negative 12 and not just regular 12. And the thing that it has to add up to is negative 4x. So I'm looking for a number that multiplies to negative 12 that adds up to negative 4. Well, this is going to be a little bit longer of a list because I now have to start thinking of negatives. So I'm going to think of everything that multiplies to negative 12. I'm going to list it out. I'm actually going to list all of it. Negative 1 and 12, 1 and negative 12, because they don't add up to the same thing. Negative 2 and 6, 2 and negative 6. Got to count for both of them. Negative 3 and 4, 3 and negative 4. Now I could keep going and just double the list, but I get repeats, and I don't need to worry about the repeats. So remember, I'm looking. These are all the things that multiply to negative 12. They now have to add up to negative 4. So which of these add up to negative 4? This one adds up to 11. This one is negative 11. This one is positive 4. This one is negative 4. Oh, done. I'm done. I don't have to keep going because I found my match at negative 4. So one of them is going to be 2, and the other one is going to be negative 6x. And notice that 6x and 2, they add up to negative 4. The diagonals multiply to be the same thing, and all we're going to do is common factor. So pull out things that are common. So I'm going to pull out a negative 6. We're left with an x. Left with an x. And this has got to be 2. So our factored form is going to be x minus 6 and x plus 2. And this is our final answer, our factored form. Now try the second activity for this week. Review this video if you get stuck or have questions. And be sure to attend your teacher's Zoom office hours or email them if you have questions. This is a tricky topic. These problems take a lot of time to think about and a lot of practice. Try one problem while you're watching one of the videos. They do get easier when you practice more. So the more you practice and the slower you go at first, you'll pick it up really quickly. Be patient with yourself and ask your teacher for help. Do attend their office hours. We'll hope to see you in the next video.